Hello, welcome to lab. Today we're going to do experiment 1, density of liquids and solids. The first thing we're going to do is read the temperature. Density varies with temperature, so it's always important to record a good temperature before you start your experiment. I'd like you to read this. This thermometer is 0 to 100. The smallest division is in ones, so we'll read to the ones and estimate to the tenths. Please read this thermometer. We're going to start in with the procedure. I'd like you to follow along in your lab manual. The first step says obtain about 80 milliliters of 2-propanol, and I've already done that. And then in steps 2 and 3, the burettes need to be normalized, one with DI water and one with 2-propanol, and then they'll be filled to over the 0 mark and then drained to below the 0 mark, and then we will read them. I'll do the reading and you can record the value on your data sheet. In step 4, we will weigh a clean, dry, and stoppered 50 milliliter Erlenmeyer flask. Please record this value on the data sheet in the water column in the mass of flask and stopper row. Record all digits of the balance with units. In step 5, we'll dispense approximately 10 milliliters of DI water to this flask. I'd like you to read this burette reading. In step 6, we need to reweigh our flask, stopper, and the DI water sample that we just delivered to the flask. Please record this value in the mass of the flask, sample, and stopper row in the water column. Next, we'll repeat this procedure for pure 2-propanol. We'll weigh a flask and a stopper. Next, we'll deliver approximately 10 milliliters of the 2-propanol to this flask. I'd like you to read the burette. Next, we need to reweigh the mass of the sample, flask, and stopper. I'd like you to record this value and then enter it in the mass of sample and flask and stopper row in the 2-propanol column of your data sheet. You can now calculate the densities of pure DI water and pure 2-propanol. You don't have to show your work, but please include units in your final answer. Please pause the video while you're calculating the densities. Let's proceed to part 2, making the DI water 2-propanol solutions. I'll do the water part and you do the 2-propanol part. In the first test tube, we'll have 15 milliliters of water and 30 milliliters of 2-propanol. And in the second test tube, we'll have 30 milliliters of water and 15 milliliters of 2-propanol. I'll drain water into both of them. Something that you need to be aware of, before you start adding to your second test tube, be sure you have at least 30 milliliters, which is the amount I need, available to deliver in the burette. If not, refill the burette and make some new readings. Carefully read and record the following 8 measurements in the appropriate box in your data sheet. Next, I'll mix both of the solutions. You'll need to calculate the mass percent water in each of the solutions. First, calculate the volume of DI water and 2-propanol in each test tube from the burette readings. This value should go in the 3rd row of each table. Next, using the volume you just calculated and the densities you determined in Part 1, determine the mass of the DI water and the mass of the 2-propanol in each test tube. These values go in row 4 of each table. Adding the DI water and the 2-propanol masses together from one of the test tubes, you can determine the total mass of the solution. Finally, you can determine the mass percent water for each solution. Pause the video while you are completing these calculations. In Part 3, we'll determine the densities of the 2 solutions we just made. The first step in this part is to weigh a clean, dry Erlenmeyer flask with a stopper. Let's do that. We now have to normalize our pipette with the first solution that we'll be using, and then I'll pipette a 10 milliliter aliquot, or a sample, into my flask, and then I'll reweigh the flask, stopper, and sample. So first, I will normalize this pipette, and again, that's just coating the inside surface. And just a little bit above the line, and then we'll put this to waste. So now my pipette is normalized. And then I will draw up my sample. Again, I'll go over the mark, lift my pipette out, and then either use the top or the side wheel or the lever, my favorite is the top, to get the meniscus on. And there we go. And deliver that to my flask. You may see a little bit of liquid still in the pipette when you're done. These pipettes are calibrated to deliver, so that is okay if you see a little bit in the pipette. Now let's weigh this. We'll now repeat the same procedure for the 2-propanol, and we'll make sure that we normalize the pipette again with our new number 2 solution. Now you need to graph your data, density versus mass percent water. There's graph paper at the back of the manual. There is a lot of graph help in the manual in this step. Be sure to orient the graph landscape. Scale the graph appropriately. You will need to have 0 to 100% for the mass percent water, and for the density, start at about 0.7500 grams per milliliter. That should be the low end of the graph, so the graph is not compressed in a very small space. Be sure to label your axes. You should have 4 points on your graph. Connect them in a smooth line. Pause the video while you're constructing the graph. Now that you've constructed your graph, we can resume with part 4. The first thing we need to do is weigh a clean and dry Erlenmeyer flask. In step 2, we'll dispense 10.0 milliliters of our unknown 2-propanol water solution to our Erlenmeyer flask. First, we'll gently lift up on the barrel, and if there's a drop that comes up, it will go to our waste beaker. Then I will gently push down and deliver the solution to our Erlenmeyer flask. I'll stopper it and reweigh it. While you're here, be sure to record the unknown number. Record this value on the data sheet, and also record the mass on the data sheet in the mass of sample and stopper and flask row. Calculate the mass of the solution from your data. Using this mass and the volume, calculate the density of the solution. Using the graph you've constructed, determine the mass percent water in the unknown. Pause the video while you're determining these values. In part 5, we'll determine the identity of a solid by calculating its density. First, we'll weigh the solid. Next, we'll add water to a graduated cylinder, and we'll read it. This graduated cylinder is a 10 milliliter graduated cylinder, and the smallest division is 0.1 milliliter. So we'll need to estimate to the hundredth. I'd like you to read this. Now we're going to add all our solid, and please make note of the unknown number, to the graduated cylinder. And we can now read the final volume. From this, you can calculate the density of the solid and determine what the identity of the solid is. Compare your density to the table in the lab manual to determine this. Now that we're done with the lab, we need to clean up. We need to completely dry the solid and return it to its original container. We need to rinse the burettes with DI water and then flip them and open the stopcock. And then we need to arrange all of our equipment neatly so the next group can use it. Thank you for being my lab partner. To complete this lab, you will need to write a conclusion and complete the error analysis. This week, since it's the first conclusion you are writing, we will tell you exactly what we need and the format. In later labs, you will be required to follow this method. First, in 1 to 3 sentences, sum up the purpose of the lab. Help specific to this lab is given on the first page of this lab in the outlined box. Next, in sentence form, give relevant data from your data sheets. In this lab, include the following, and you may want to follow along in your data sheets and star these items to remind you to include them in the conclusion. Temperature of the experiment. Densities of pure DI water and pure 2-propanol. Density and mass percent water of solution 1. Density and mass percent water of solution 2. Unknown number, density, and mass percent water of the unknown solution. Unknown number, density, and ID of the unknown solid. You will need to write in what is called third-person objective. This means no I, we, our, etc. in your paragraph. State things like this, and I'll give data here from another experiment for illustrative purposes. It was determined that the density of pure DI water was 1.0002 grams per milliliter, and the density of pure 2-propanol was 0.7506 grams per milliliter. Don't cloud a good conclusion with unnecessary data. For example, no one needs to know the initial and final burette readings, or even the volume of the solutions here. What's really important are the densities and mass percent water. Always include unknown numbers. Finally, you will need to complete the error analysis, which are the 2 questions at the bottom of the data sheet.